Hey everybody, how you doing today? We're going to be looking at slopes and rates of change today in this lesson. It's more or less an intro to slope, so I want to give you some basics. We may go over that in another video, and then we're going to see how it applies to direct variation, which is used a lot in high school. So this is going to be a very useful introduction type of lesson for you. I hope you find it useful. You may want to watch it a couple times, like I said. Make sure to subscribe, like, comment, all that will help me out to make this channel grow. I greatly appreciate it. All right, as I said before, this is one of the more introductory types of ways to graph a slope and point on a line. The first thing we need to do is realize that this is our slope, the -1/3. Once again, not to be confused with a fraction. This is indicating the slope. The big thing that we have to look at here is this negative. All right, that gives we get a lot of clues from this. So if we're thinking of a mountain, all right, I do this with my kids as an introductory. We're always going to move left to right. All right, so if we're going uphill, right, we're increasing our altitude. So it's going to be a positive number. We're going up, we're increasing the number. As we move down, it's going to be negative. So what we need to take note of is this right here. The slope goes up, a positive. The slope goes down, it's a negative. And then that'll give us enough information to graph this. So this is our starting point, right? So if you haven't looked at our video on graphs, ordered pairs, I would suggest to do so. So the -3 is your x, so we're going to go back 3. And then the +5 is your y, so we're going to go up 5. So back 3, up 5, which will give us this point here. Now, as I said, this right here indicates that we're going downward. The 1 and 3, this is known as your rise over your run. So you have to do your rise is your up and down, all right? That would be considered your y. And then your run is your side to side, which is your x, okay? So if it's negative, let's go down 1. So we're going to go down here to 1. And then we're going to go to the right 3. 1, 2, 3. All right, that's our next point. And then we'll do the same thing again just to make sure that the line's nice and straight. We go down 1. That's our up and down, our rise. And then we go to the right 1, 2, 3, and our points right here. All right, then what we can do, and typically you'll have a ruler of some sort. You can draw this line right through there, and that will give us our slope. And notice that the fraction 1/3, there's not much steepness. If it's an improper fraction, although they're not really fractions, it's going to be much steeper than what we see here. All right, let's take a look at this new problem here. So we can see that this time there's nothing in front. So that, just like when we were dealing with one-step equations, we assume that it's positive. So this is actually our starting point, the 2 and 1. We have x, y. So this should put us in the first quadrant. So we're going to go to the right 2, up 1, and this is our dot. Now remember, 1, 2, rise over run. This is your y, this is your x, this is your up and down, this is your side to side. So it's a +1, we're going to go up 1, and then over 2. Here's our next dot. Up 1, over 2. Now I suggest not to draw these little steps in on your paper. Starting out, you might be able to do that, but I don't know if teachers would be happy with that, but it is a good way to start out. So we're going to connect these to the best of our ability here, and you can see that it's going uphill. 1 to 2, not much of a huge slope, right? But you know, this is something that they use when they're making steps. I knew I did that when I took architecture in high school, but you know, definitely has a real world application if you're talking about slope and trying to make like skateboard ramps, snowboard kickers, and all that. This is exactly up right there. All right, so we're going to take a look at this graph here, and it asks, the graph at the right shows the cost per pound of buying apples. So the first part asks, is the cost per pound a constant or variable rate? Well, in order for it to be a constant rate, we know that it has to cross through 0. Excuse me, and if we look, it does cross through 0, so that's the easy part, that's a yes. And then what we want to do is find out what the cost is per pound. So this actually should be labeled pounds, and then this is going to be the cost here. Okay. if they're asking per pound, well, this is where kids have some issues when we go through this. They make it more difficult on themselves. So if we're looking per pound, well, 1 would be right here. So let's see where 1 lines up. And if we look, it's slightly between 2 and what would be 3. So the cost per pound of apples is $3.50. Oh, I'm sorry, not $3.50. It should be $2.50. All right, and then if we look here, we go to 2. It's like at $5, so we would do $5 divided by 2, and then we see here 750 divided by 3 is 250. So make it easier on yourself and look at 1. All right, everybody, that concludes our lesson on slope and rate of change. Keep in mind that is a bit of an introductory type of lesson. We will see some more with that as we progress with some of these videos. It's definitely good to go back and just see how you determine what the slope is, whether it's going uphill or downhill. All techniques that I've used when I was in middle school, high school, but it is something that is an ongoing thing, especially throughout high school. So good thing to look at to start out with, a great reference. Keep all that stuff in mind as you go forward with your work. I hope it worked out for you, and I hope it was useful. Take care.